Hello Tech World, this is TechThoughts. In this video we'll be demonstrating how to upgrade a hypervisor cluster from 2012 R2 to Nano Server, and attempting to do so with zero downtime to the VMs. As always, if you prefer written documentation, the corresponding write-up for this topic is on the techthoughts.info blog. Let's go ahead and get started. Okay, as you can see here, I have a basic failover cluster Hyper-V type with two Hyper-V nodes, Hyper-V 1 and Hyper-V 2. And both of those are running 2012 R2, as you can see here, Hyper-V 2. And if we hop over to Hyper-V 1, that is also running 2012 R2. Nothing special here, just a two-node hypervisor cluster. And if we look at the roles, we're running one tenant VM, also running 2012 R2. And we're going to attempt to upgrade Hypervisor 1 to Nano Server without causing any downtime to this 2012 R2 tenant VM. So let me just demo real quick that everything's working as expected. We can live migrate this over to Hype 1, and that VM will hop over to Hype 1, and I can live migrate it back to Hype 2. And now that all of my VMs are over on Hype 2, what I'm going to go ahead and do is eject that Hypervisor 1 from the cluster. So I'm going to come into nodes, and I'm going to pause this and go ahead and drain. There's nothing on it, but I'll go ahead and drain it anyway. That's in a pause state right now. And with it in a pause state, I'm going to go ahead and evict it from the cluster. All right, so we're now sitting on a one node cluster with just Hyper-V 2 inside of it. And Hyper-V 1 at this point is essentially just a Hyper-V server and is no longer part of that cluster. So what I've done to prepare this device for transition to Nano Server is I've copied the Nano Server image over to C Nano folder on this local Hyper-V 1 device. If you haven't seen my videos on how to create a Nano Server image or how to customize the Nano Server image, I definitely recommend that you check out those two videos before proceeding any further. So I set up this Nano image to essentially mirror all the settings that this normal 2012 R2 server already has. It's going to have a slightly different host name with Hyper-V1N, the N being for Nano, versus the Hyper-V 1 it has now, but this is set up to automatically join the same contoso.local domain. So if we take a look at this post-configuration script, what I've essentially done here is I've pre-identified all the things on the 2012 R2 version of the server, and I have this script looping through and setting things back to their original state. So it'll find the original MAC address of some of the NICs and put the proper IPs back on those, the DNS entries, gateways. So when the Nano Server starts up, it essentially has the same configuration with virtual switches and etc. as this 2012 R2 hypervisor. So this customization script is already loaded inside of my Hyper-V1N image, which is located on this hypervisor, as well as the domain blob file so that I can rejoin the domain. So with this evicted from the cluster, and with my Nano Server hypervisor image customized and ready to deploy, all I need to do now is mount this VHDX. So notice that I've gotten an E drive letter here, and what I now need to do is modify the boot parameters of this hypervisor so that instead, after a reboot, instead of it coming and booting back into the 2012 R2 OS, it'll instead boot to the Nano VHDX. This can be easily accomplished with the bcd boot command and specifying the location of your Nano VHDX Windows folder. I'm going to go ahead and execute this command now. And you can see that the boot files have been successfully created. At this point, this device is ready to reboot, and instead of booting up into 2012 R2, it will reboot back into that Nano Server image. One of the nice things about this upgrade process is if anything doesn't go as expected on the Nano Server side, you can simply reboot the device again and boot back into 2012 R2. So this provides a very easy to implement rollback plan in the event that your Nano Server deployment doesn't go as expected. With all that accomplished, the server is ready for reboot. I'll go ahead and initiate a reboot now. We can go ahead and monitor that status by hopping over to DRAC, since this is a Dell device, and we can monitor the progress of that reboot, as well as determine if the post-deployment scripts that we've put in our Nano Server image are functioning correctly, as we should see that original IP pop up and start responding to pings once those customization tasks are complete. All right, with that Nano server started up, the SetupComplete.cmd file is going to kick off, which is going to kick off our customization script. And in a few short moments, we should see pings come back as that script properly provisions our IPs. There we see a good IP return as that NIC has been re-IP'd on that 10.0.3.191 IP. Followed by a short interruption as our Hyper-V virtual switch is provisioned. Virtual switch has been completed. We get good IP returns again. And the script is set to pause for a few seconds. And we should see this wrap up with a domain join followed by a quick reboot. And there's our reboot and drop an IP. When this comes back up, we should have a fully operational Nano server. Okay, and with that reboot complete, I'm going to hop back over to Hype-V2. And at this point, we should be able to add that Nano server back into the cluster. So I'll come to add node. And our new name for that server is Hype-V1N. And since that's joined to our domain, we got a good DNS record for that. I'm going to click next. It's always a good recommendation to run the validation tests, but for the purposes of this video, I'm going to skip that step as that takes a little bit of time. I'm going to go ahead and click no and next. I don't want to add the local storage of that hypervisor into this cluster, so I'm going to decheck add all eligible storage and click next. And Hype-V1N is an eligible node back in my cluster. As you can see down here, operating Microsoft Windows Server 2016 Data Center with Nano Server Edition. As I had my networking stack re-provisioned back exactly the way it was before when it was 2012 R2, the same virtual switches and IPs are all in place. So we can complete this with the ultimate test of seeing if we can live migrate this 2012 R2 tenant VM back to that Nano server. And there you have it. At this point, we could just recreate that exact same process on the Hype-V2 server. We could drain it, eject it, mount the VHDX for that image of Hype-V2, give it a reboot, make sure it re-provisions correctly, and then bring it back into the cluster. We would have completed a complete cluster upgrade, moving from these two nodes being 2012 R2 to 2016 Nano server. This was obviously a very brief demonstration, and there's a lot of considerations to take into account when moving a production workload from one operating system to another. So definitely do this in some lab testing before rolling to production. There are some significant differences between 2012 R2 and Nano server, and you should familiarize yourself with those differences and make sure that Nano server is a good fit for your environment. Let's close out this demonstration by doing a quick WinRM session to that hypervisor. So we'll open an ISC window, and we'll do a enter PS session since we enabled WinRM on that Hype-V1N image. And now we're sitting on a command line for that Nano device. As you can see, when I type hostname, I get Hype-V1N back. And we can just verify that we can manage the server remotely, and it is running our test VM 2012 R2 tenant. I hope you found this short demonstration on how to upgrade your existing Hyper-V cluster from 2012 R2 to Nano with no tenant downtime useful. And don't forget to check out the corresponding article on TechThoughts.info blog.